Weirdest construction machines ever made, explained. Machine 1, the spider. This machine has 4 legs. It can climb a 70-degree mountain slope, and it weighs over 10 tons. Meet the Menzie Muck M545X, the walking excavator. Normal excavators sit on tracks and can only work on flat or mildly sloped ground. The moment the terrain gets steep, they tip over and become very expensive scrap metal. So Swiss engineers asked a simple question: what if it had legs instead? The Menzie Muck has 4 hydraulic limbs that move independently, each one bending, extending, and gripping like a claw. The cab automatically levels itself no matter how extreme the angle. The operator inside feels like they're sitting on flat ground, while the machine is essentially crawling up a cliff face. It's used in the Alps for work that no other machine can reach: forest clearing, pipeline installation, rocky terrain that would stop anything else cold. The weirdest part? It can also swim. Attach pontoon floats and it wades into rivers to dredge the bottom. A machine that walks mountains and swims rivers. They built a spider. Machine 2, the earth saw. Imagine taking a chainsaw. Now make it 20 feet tall. Now drive it through the ground at walking speed. That's the Vermeer T755-3 trencher. Digging trenches the normal way, with a bucket excavator, is slow, expensive, and imprecise. You need to lay cables, pipes, and sewer lines for miles. There had to be a better way. So Vermeer built a machine with a massive rotating chain of cutting teeth, exactly like a chainsaw, mounted vertically on the rear of a tracked vehicle. As it moves forward, the chain chews through soil, rock, and clay, and throws the material to the side in one continuous motion. It cuts a perfectly clean trench, exact width, exact depth, in a straight line, mile after mile, without stopping. The machine can slice through ground at up to 600 feet per hour. A job that would take a crew of excavators several days takes this machine a single afternoon. The sound it makes doing this is deeply unsettling, like the earth is being unzipped. Machine 3, the water walker. This is a normal excavator, except it's standing in the middle of a lake, digging the bottom, and it drove there. The amphibious excavator works by mounting a standard excavator cab and arm onto a set of pontoon floats, long hollow tubes that sit on the water's surface. Steel spud legs pin it in place so it doesn't drift while it works. But here's where it gets strange. It doesn't need a boat to get to the water. It walks in. The undercarriage has extended track pads, wide, flat, and designed to spread the machine's weight across soft mud and shallow water. It can cross swamps, wade through flooded construction sites, and lower itself into rivers inch by inch. They're used for dredging rivers, clearing flood-damaged canals, and building foundations in waterlogged ground where no other machine can operate. It's an excavator that decided land was optional. Machine 4, the Dumpfo. Someone looked at an excavator and a dump truck and thought, why are these two separate things? The Dumpfo, built by Keltec Engineering, is exactly what it sounds like. Excavator arm and bucket on the front, dump bed on the back, one machine, one operator. One very confused-looking vehicle. It ran on 4 wheels instead of tracks, powered by a 92-horsepower Caterpillar engine, with 4-wheel drive steering and a top speed of 20 miles per hour. The idea was simple: dig with the front, load into the back, drive to the dump site, tip the load, come back, repeat. No second machine needed, no waiting. On paper, it should have revolutionized small construction sites. In reality, it never went into mass production. The arm wasn't powerful enough for serious digging. The dump bed wasn't large enough for serious hauling. It tried to do 2 jobs and ended up not quite nailing either one. But it exists, it ran, and it looked absolutely ridiculous doing it. Machine 5, the Mole. In 2013, a machine named Bertha was lowered 200 feet underground in Seattle. Its job was to drill a 2-mile highway tunnel beneath the city. Its diameter was 57 feet, wide enough to drive a 4-lane road through. Tunnel boring machines work by pressing a giant rotating disc of cutting teeth against the rock face. As it spins, it grinds through everything: soil, clay, solid rock, while a conveyor belt carries the debris backward out of the tunnel. Behind the cutter, the machine simultaneously installs concrete ring segments to form the tunnel walls. It moves forward about 35 feet per day, non-stop, 24 hours. Bertha got 1,000 feet in and hit an old steel pipe. The impact damaged her cutting head. The repair required digging a rescue shaft 120 feet deep from the surface to reach her. She sat underground, Broken, for 2 years. They fixed her. She finished the tunnel in 2017. The machine that was supposed to take 2 years took 4. But the tunnel exists, and Bertha did it alone, from the inside, in the dark. Machine 6, the hill climber. Most machines tip over at 30 degrees. This one works at 55. The Menzie Muck. We've already met the spider, but there's another machine solving the same steep slope problem in a completely different way. The self-leveling dozer. Machines like the Emer Combi and specialized hill climber dozers use a hydraulic pendulum system inside the chassis. As the ground tilts, the system detects the angle and automatically shifts the cab and blade to compensate. The operator sits level. The tracks grip the slope. The blade pushes material downhill as if it's working on flat ground. They're built for mountain forestry, clearing land on hillsides that are basically cliffs, in conditions where a standard dozer would simply roll over and tumble down. The strangest thing about watching one work is how calm it looks. Machine on a near vertical slope, cab perfectly level, moving like it's bored, engineering making the impossible look unremarkable. Machine 7, the Planet Eater. This is the largest land vehicle ever built. It is not close. The Bagger 293 is a bucket wheel excavator operating in a coal mine in Germany. It weighs 14,200 tons. It is 96 meters tall and 225 meters long. It has a crew of 5 people. At one end is a rotating wheel, 21 meters across, studded with 18 massive steel buckets. As the wheel spins, each bucket scoops up 15 cubic meters of earth and dumps it onto a conveyor belt that runs the full length of the machine. The conveyor moves 240,000 cubic meters of material every single day. It moves on 12 crawlers, sets of tank tracks so large that a person standing next to one barely reaches the top. Its top speed is 0.6 kilometers per hour. It cannot be transported. It was assembled on site and has been mining the same region since 1995. It will never leave. There is no machine on land that comes close to its size. It makes a standard excavator look like a toy left in the dirt. And it runs continuously, day and night, consuming entire landscapes one bucket at a time. Machine 8, the Ghost. In 2025, Komatsu unveiled a machine with no cab, no seat, no operator inside. The amphibious remote-controlled underwater dozer can operate at depths of up to 160 feet below the surface. The operator sits on shore, watching a live feed from cameras mounted on the machine, and controls every movement via a remote console. The dozer itself is fully electric. No emissions underwater, no exhaust. Silent except for the hum of its tracks on the riverbed or lakebed it's clearing. It uses mapping and visualization technology that builds a 3D picture of the underwater terrain in real time, so the operator can see the ground the machine is moving, even through zero visibility water. The intended purpose: clearing riverbeds, removing sediment from dam floors, and underwater construction work. All jobs that currently require expensive diving operations or specialized underwater vehicles. The operator stays completely dry. The machine goes where humans can't. It's a dozer, it's a submarine, and in 2025, it was just a concept. But it ran, and it worked. And what comes next will be stranger still. Machine 9, the Spider Lift. This machine needs to get a 100-kilogram lighting rig to the top of a cathedral ceiling, 120 feet up. The entrance is a standard doorway. There are stairs. A normal boom lift is the size of a truck. It can't get through the door. It certainly can't climb stairs. The spider lift folds itself down to the width of a large wheelchair. It rolls through the doorway on rubber tracks. It finds an open space on the floor. Then it unfolds 4 stabilizer legs outward, like a spider, anchoring itself to the ground. The boom extends. Up, jointed and articulated, reaching over obstacles and around columns that a straight boom couldn't pass. The platform at the top reaches 160 feet from inside a building. The legs can also adjust for uneven ground, stairs, and cambered floors. Each leg extends independently, hydraulically leveled, so the machine can set up on surfaces that would stop any other lift cold. They work in concert halls, historic churches, aircraft hangars, and film sets. Anywhere the ceiling is high and the access is impossible. From the outside, it looks like a machine that shouldn't fit, shouldn't reach, and shouldn't work. It fits. It reaches. It works every time.